What if I told you that by 2028, we could have a computer so powerful it makes today's supercomputers look like pocket calculators? IBM just announced they're building something called Starling, the world's first large-scale, error-corrected quantum computer. This isn't just another tech upgrade, folks. We're talking about a machine that could revolutionize medicine, crack climate change, and solve problems we didn't even know were solvable. The race is on, billions are at stake, and the winner will literally reshape our future. But here's the kicker. IBM thinks they've already cracked the code that's been stumping scientists for decades. Let me break down why this matters by explaining the biggest headache in quantum computing. Imagine you're trying to solve the world's most complex puzzle, but every few seconds, someone randomly flips a few pieces. That's essentially what happens with today's quantum computers. They're incredibly powerful, but also incredibly unreliable. Regular computers use bits that are either on or off, like light switches. Quantum computers use something called qubits that can be both on and off simultaneously. Think of it like a spinning coin that's both heads and tails until it lands. This gives them mind-blowing computational power. But there's a catch. These qubits are extremely fragile. They're kept at temperatures colder than outer space, and even the tiniest vibration can mess them up. When one qubit makes an error, it spreads to neighboring qubits like a virus. It's like trying to perform brain surgery during an earthquake. Technically possible, but the margin for error is impossibly small. Current quantum computers can only run for a few thousand operations before errors pile up and the whole thing becomes useless. It's like having a Ferrari that breaks down every few miles. Sure, it's fast when it works, but you can't rely on it for the journey that matters. This is why quantum computers today are mostly expensive science experiments rather than practical problem-solving machines. Here's where IBM's breakthrough gets exciting. They've figured out how to build quantum computers that can catch and fix their own mistakes in real time. Think of it like having an army of proofreaders constantly checking and correcting typos as you write. Except these typos are quantum errors that could derail entire calculations. Their secret weapon is something called error correction, but not just an error correction. They've developed a system that's incredibly efficient. While competitors need 100 physical qubits to create one reliable logical qubit, IBM's method only needs 12. That's like needing 12 backup singers instead of 100 to make sure you hit the right note. But here's the real game changer. Their Starling computer will have 200 of these error-corrected logical qubits and can perform 100 million consecutive operations accurately. To put that in perspective, that's like going from a car that breaks down every few miles to one that can drive around the world without stopping. They're not just talking big either. They've already started construction on a dedicated facility in New York. Their roadmap is methodical. They're building smaller test machines first, then scaling up module by module until they connect around 100 modules to create Starling. It's like building a space station piece by piece, except this space station will be computing at the quantum level. Let's talk about how this quantum revolution will actually change your life, because this isn't just tech industry hype. This is going to touch everything. First, medicine. Imagine discovering new life-saving drugs in months instead of decades. Quantum computers can simulate molecular interactions with precision that's impossible today. We're talking about personalized medicine where treatments are designed specifically for your genetic makeup, cancer therapies that target only diseased cells, and maybe even solutions to diseases we've been fighting for generations. Climate change? Quantum computers could help us design revolutionary materials for solar panels that are 10 times more efficient, or create carbon capture systems that actually work at scale. They could optimize energy grids so perfectly that we eliminate waste entirely, or help us develop fusion power that finally makes clean energy cheaper than fossil fuels. Your daily life will transform too. Supply chains will become so optimized that shortages become a thing of the past. Financial markets will operate with precision that eliminates many economic uncertainties. Weather prediction will become so accurate that we'll know exactly when and where natural disasters will strike, saving countless lives. Even artificial intelligence will get a massive boost. The AI systems powered by quantum computers will make today's ChatGPT look like a basic calculator. We're talking about AI that can solve complex scientific problems, design new technologies, and maybe even help us understand the fundamental nature of the universe itself. This isn't just IBM working in isolation. We're witnessing the most intense technological race since the space program. And whoever wins first will dominate the next century of technology. Google has their surface code approach, but it's incredibly resource-hungry, requiring 100 physical qubits for every logical one. It's like needing a football field to park a single car. Amazon's taking a different route with their Ocelot system, which is more efficient but still behind IBM's approach. Then you have scrappy startups like Quera and 𝐶𝐸 trying to leapfrog everyone with completely different technologies. But here's why IBM might have the edge. They're not just building the computer, they're building the entire ecosystem. They have decades of experience in enterprise computing. They understand how to scale manufacturing, and they've got the business relationships to actually get these machines into the hands of researchers and companies who need them. The stakes couldn't be higher. Whichever country masters quantum computing first will have an insurmountable advantage in everything from national security to economic competitiveness. It's like having gunpowder when everyone else is still using swords and shields. The race is so intense that some experts predict we'll see multiple breakthroughs in the coming years, with different companies excelling in different applications. But if IBM delivers on their 2028 promise, they'll be the first to cross the finish line. Now, let's pump the brakes and talk reality. Building the world's first large-scale, error-corrected quantum computer isn't just difficult. It's the kind of challenge that keeps engineers awake at night. First, there's the technical complexity. IBM is essentially trying to conduct a symphony orchestra where every musician is invisible, incredibly sensitive, and prone to playing the wrong notes if you look at them funny. Scaling from their current small-scale demonstrations to a 200-qubit system is like going from building a paper airplane to constructing a space shuttle. Then there's the timeline pressure. 4 years might sound like a lot, but in quantum computing terms, it's incredibly ambitious. Every component needs to work perfectly, from the individual qubits to the error correction algorithms to the classical computers that control everything. One major setback could delay the entire project by years. Manufacturing is another huge challenge. These aren't regular computer chips you can mass produce in existing factories. Each quantum processor requires precision that makes smartphone manufacturing look simple. They need to maintain near absolute zero temperatures, perfect isolation from external interference, and flawless connectivity between components. Even some experts are skeptical. While they praise IBM's roadmap as realistic, they question whether 100 million operations will be enough to solve truly useful problems. Some estimates suggest we need 1 billion operations for practical applications. It's like building the world's fastest car, but discovering the racetrack is longer than expected. So here's my question for you. When quantum computers become mainstream, what problem would you want them to solve first? Climate change, disease, traffic jams? Drop your thoughts in the comments because I genuinely want to know what matters most to you. If this quantum revolution excites you as much as it does me, smash that subscribe button and hit the notification bell. Trust me, the next few years are going to be wild, and you don't want to miss any of these breakthroughs. Next week, I'm diving into Google's quantum response and why they think IBM might be wrong. Until then, keep questioning everything.